Today we'll be discussing polynomial functions, as we've already done the general discussion on functions. What is a polynomial function? What is
Welcome back, and sorry for the technical issue that we have. Let's continue with our discussion. As I mentioned earlier, we are discussing polynomial functions today. So far, we've discussed functions where we define a function as an ordered pair in which no two second elements have the same first element. In this discussion, we're discussing a specific or a special type of function referred to as polynomial function. As can be seen on the screen, a polynomial function is a function of the form px is equals to an xn in the contracted form or in the standard form as we have over there, where our n is a non-negative integer, which means that n can start from 0, move on to 1, 2 onwards. The basic distinction here is that in a polynomial function, the exponent n cannot be negative or a rational number in the term of a fraction or something. So for example, if we have a function of the form f of x is equal to 2x squared plus 1, we ask ourselves, what's our power in the expression here? We see that the power is what? 2. Is it a positive number or a positive integer? And we say what? Yes. Therefore, this will be an example of a polynomial function. In other words, if we have another function of the form 3 on x to power, let's say 4, we may still consider this one to be a positive exponent, but we should remember that we can write this one actually as x to power -4 when we write it in linear form. So therefore, this will not qualify as a polynomial function because in this case, the exponent will become what? negative. Similarly, if we have another function of the form g of x is equals to 4 root x, for example, then in a standard form of making this one an exponent, this can be written as 4x exponent 1. As you remember in class, exponent half. This is also a fraction, so a radical. We cannot decide to accept this as a polynomial function. The baseline, therefore, is that a polynomial function is a function of the form an x to the power n, where n is a non-negative integer, or an integer that is always 0, 1, 2, 3 onwards. Let's take some example of polynomial function or types of polynomial function. We name polynomial functions in two different ways, either using the number of terms in them or the exponent. When we say a term, terms are expressions separated by addition and subtraction. So we may want to take a term simply as what? As if we have f of x equals to 1 plus 2x plus 4x squared. We ask how many terms do we have in this function? And we say terms are separated by addition. So we have one addition sign and another addition sign. So we have 1, 2, 3 terms in this function. Now when there are 3 terms, we are going to refer to this one as what? Trinomial, because there are what? 3 terms. So we name polynomials as monomial, polynomial, or trinomial based on the number of terms in it and upwards. One way of naming them, so we can have a monomial, which is a function of one term, 2x, let's say, squared. There's only one term in this, so it's a monomial. Then what we have up here is a polynomial. Should we take off the third term, this one becomes a polynomial in that regard. Then we can also name a polynomial based on the exponent or the power. And we say that the degree of a polynomial is the highest power it has, or the highest power it has in it. So this one has a power 2, so this one will a polynomial of degree 2. This one has what power? Power 1, so a polynomial of degree 1. And should we have y is equals, let's say 5, where we have no variable x in it, this one will be a polynomial of degree 0, because as you know from our indices, this will have x to the power of 0 present. Therefore, this will be a polynomial of degree 0. So let's see on the screen our type that we can be dealing with. We have a constant function, that's the one we just wrote, a polynomial of degree 0, where the variable is not there, but we know it's exponent 0 present. That's a polynomial of degree 0 is what? A constant function. A polynomial of degree 1 is called or referred to as a linear function. And of degree 2 will be a quadratic function. Degree 3 will be, as we have in there, going to cubic function and quartic and then 20. These are the various types. But in our discussion in elective mathematics, we usually limit ourselves up to the cubic function. Though some few cases we meet some function that goes beyond the cubic. That happens rarely in elective, but going forward, you can have polynomials of this degree. So we have just mentioned that polynomials are either named based on the number of terms or the number of the power or the highest degree in it. So assuming that we have a polynomial function p of x defined as 6 minus 5x, let's say, plus 7x squared. Then we say name this polynomial. Then we can name it in two ways. This will be a trinomial and a quadratic, but it has 1, 2, 3 terms, and the highest degree or power is 2. So this is a trinomial and a quadratic. So the general form of a trinomial is a quadratic in that regard. So now, polynomials in general can be evaluated just by, as we just learned earlier on, putting your values. So assuming that we have a polynomial p of x defined as 6 minus 7x, as we learned earlier on, plus x squared. Then we can say that we will evaluate p of, let's say, 2. The same way as we have evaluating our functions, we simply have to put 2 wherever we see x, and that will become 6 minus 7x, that is in this case x is 2 plus 2 squared, and that gives us 6 minus 14 plus 4. If we are adding 6 and 4 will give us 10, minus 14 will give us negative 4. So p of 2 would be 4. The same way as we were discussing the case of functions. Now let's see our first example to illustrate our work. Let's try our hands on the work. F of x is equal to x cubed plus 2x squared minus x plus 3. first, before you start the expression, name it, appropriately name it, at least in terms of the degree, and then evaluate f of minus 2 and f of what? 0. I will give you some 1 minute to what? Evaluate, or let's say 30 seconds to evaluate even the first one, f of minus 2. So our result is f of x is equals to x cubed plus 2x minus x plus 3. And we have to evaluate I, f of minus 2. F of minus 2. As we did the first one, or this one you'll be able to do it, let's verify whether our result is what? Consistent. F of minus 2, as we mentioned, function simply put the minus wherever you see it. And remember that when it comes to dealing with negative values, once you're fortunately your f is carried with f of minus 2, carry the whole of this in your substitution. Don't carry only the minus 2. Therefore, you're going to have minus 2 cubed. And make sure that your exponent is outside your bracket. If it's inside, that's as good as not writing it. Then plus 2 minus 3. Okay, we have a square here. Sorry on that. Exponent 2, then minus of minus 3, then plus 1. Minus of minus 2, and then plus 1, 3. So that would be our substitution, where we have carried the negative 2 together with the brackets, and very, very important, especially when you are punching calculators, you can get results in that. So negative 2 cubed will come what? As we have like 8. Then when we square the negative 3, we have a negative 2, sorry, we are going to get positive 4 times 2, that's also going to be what? 8. Then the negative and the negative will become our plus 1, 2, then plus 1, 3. So at the end of the day, what we have a neutral term here, minus 8 plus 8, then the result will become what? 5. That's also an example of what? Evaluation. So f of minus 2 will be what? 5. And I hope you got it what? Let's try f of 0. Let's try f of 0. And remember, we don't actually waste much time in elective mathematics. F of 0, as you know, everything that contains x will end up becoming what? 0. So much as you may want to do the substitution, which you don't have any fault with, sometimes you must just be smart. So f of what? 0 will become what? 3. So let's bear in mind that f of 0 of any polynomial function is going to be the constant what function. Something you have to put in mind that f of 0 will simply be the what? The constant function, because we're going to get a 0 cube, a 0 squared, and a 0 is all vanishing. And if we have this result in elective maths right away, nobody faults you. But if it's core mathematics, remember to put everything in there when we are interested in the steps in that regard. Then move on to the next example. Now, the next example is h of x is equals to what? X exponent 4 plus 5x cubed minus ax squared plus 3x minus 2. And we have been given a condition that h of minus 1 is equals to what? Minus 8. So we have to find the value of 8. Remember that every topic that we treat in elective or in mathematics has the algebra aspect. So this will be like the algebra of polynomial. We are going to just create equations and solve them. Let's approach this and see. First, we are given h of x to be equals to x exponent 4 plus 5x exponent 3 minus 8x cubed plus 3x minus 2. This is that, and we have a variable in here as well, a. Then we have been given that h of minus 1 is equal to minus what? 8. So we have to find the value of what? A. This is not a big deal. You need to just go through the normal process. Assuming that we were just asked to find h of minus 1, how would you have approached that? So let's simply find h of minus 1 and see what we get. Which means that wherever we see x, we put there minus 1, actually going to somewhere. So we get minus 1 to power 4 plus 5 minus 1 to power 3 minus a minus, this is 2 minus 1 squared plus 3 exponent minus 1 minus 2. That will be our substitution. So we have our exponent 4, exponent 3, exponent 2, the exponent 1, the exponent 0 there, the constant we talked about. Now this one requires that you just pay attention to your negatives. when a negative number has an even exponent, you know it's going to become an even number. So a positive number. Therefore, you are going to get positive 1 multiplying when a negative number has an odd exponent, is going to become a negative number. So minus 1, minus 1, minus 1, 3 of them. You have minus 1 by minus 1 by minus 1. These two will become positive, and this will make the result negative. Therefore, you are going to get minus 1. Then minus a, we have that already shown that 2 of them will become positive. Therefore, you have positive 1. Then minus 3, then minus 2. This would have been our simplification for f of minus 1 if that is what we were told to do. So simplifying further, we are going to get 1 minus 5 minus a minus 3 minus 2. Work out all the numbers and leave the variables. So we are getting 1 minus 5 minus 3 minus 2. We know that this is going to become minus 5 minus 5, that's minus 10 and 1. So we are getting positive 1, negative 9 minus 8. That's our h of minus 1. So just the first part, don't complicate the process. Work out the first part. And they are saying that h of minus 1 is equals to negative 8. Therefore, we say that that is if you have the h of minus 1 being equals to negative 8, then we're having minus 9 minus a is equals to minus 8, which then will become, you just decide to solve any way we like. Either we move the a to become positive, which is advisable. So we're going to get minus 9 plus 8 is equals to positive 1, a. Therefore, a will be equals to minus 1 as our result. Let's just go through the process. At the end of the day, we see a lot of things on the board as we already know, but the process is very simple. You know how to evaluate a function, h of minus 1. Don't allow the condition to confuse you. Simply substitute to produce h of minus 1 if this one was the only thing given to you. Then the second part is saying that h of minus 1 is going to be negative 8. So we just equate the result and get that. If we have not made any numerical mistake here, then this result will be correct. Remember, even if you commit a numerical mistake in this case, the process is actually always going to be like this, and you should always use your calculator to verify. I don't think we've made any sense and nature here. I suppose the process is clear. Let's move to the next example and try out something new. We have another case where we have been given a polynomial p of x, given as we have on our screen. P of x is mx squared minus nx plus 3. Find the value of the constant m and n if the truth set of p of x equal to 0 is half and then 3. So that's what we have there. If we are to we are given this situation, it differs from the first one only by a variable. For the first, we had one case a. Now we are having two variables m and n. You know what is going to happen? By the rule of solvability, or let's say the equation being solved, if we have two variables, then we are going to get two separate equations that we can solve for m and n. And then that's what has been given to us in the second condition. So the first part of our result was p of x is equals to mx squared minus nx plus 3. And then we have been told that when we solve p of x being equal to 0, the solution set would be a half and then a 1. So our question is, how do we approach it? It's very, very important to know what to do when you read the question. Finish reading this question, I found that I have two variables m and n in the way. And fortunately for me, I also have two values in here. In simple terms, the question is saying that this half and this 3 satisfy this equation when the p of x is replaced with 0. So let's apply the first condition. It says p of x equal to 0. So which means that whenever we see the p of x, we are going to replace with a 0. And in that case, we are going to have our x squared minus nx plus 3 equals 0. And when we solve this result, if we know the value of m and n, the result that can be a half and a 3, which means that these are the if you remember, these are the solution. They can be called the answers, or they can also be called roots, whichever way you want to think them. So we will put in the half and see that we are getting, let's check the case of so when x is equals to what? 1 on 2, we are going to get m being multiplied by 1 on 2 squared minus n multiplying 1 on 2 plus 3 equal to 0. So therefore we are going to get our m in the bracket 1 on 4. Remember that you apply your commas indices to make work easier for a second using decimal. Square the top and square the down. That will give us 1 squared is 1, 2 squared is what? 4. Minus our and that is still, we can do anything about this, and then let's go on to it. So we can choose to remove this fraction by multiplying through the LCM of what? 4. So if we do that, we are going to get m minus 2n plus 12 equals to 0. Okay, I suppose you understand that. If you multiply here by 4, we are getting your m4 will go with 4. If you multiply here by 4, the half of 4 is 2. And 3 times what? 12, 3 times 4 is what? 12, we have 0. Remember, here I have not shown working, therefore I have no issue. Assuming that I multiply here by 4, here by 4, here by 4, and leave the 0, there's an issue. So sometimes you go for elective, I go qualitatively. Just know that you are multiplying 2 by 4. And do it, instead of what? Right, saying so many, like multiplying by 4, do it. We are just multiplying by 4, and that's the result. Now, this will give us, if you are, you can also be prepared ahead of time. We see this one that our coefficient of n is 1. Therefore, we can just say that m is equals 1. If you move this one, you're getting 2n minus 12. This is what we can call equation of 1. In doing so, we have already set up that we are going to use what? The method of what? Substitution, which I've learned in commas over the period that we have been going through. Now we're also going to consider when x is equals to 3 and do the same. Now let's do that one straight away. So 3 into this will give us what? 9. So 9n minus what? 3n in this case. Then what? Plus what? 3 is equals to what? 0. So we are substituting what? 3 for x in here, which we know that once you've shown the process here, there's no need to show it here. So we are getting 9, x squared is 9, 3 squared is 9, 3 times 3n plus 3 equals 0. Fortunately, 3 is a common term here, so we are going to get our 3n minus n plus 1 is equals to 0. Then we can also decide to call this one equation 2, especially having set up equation 1 in this manner. Then we know what to do. We are just going to substitute your expression here for our n and solve. I think at the end of the day, we are going to get something like 6n minus what? 36. So 3 we multiply what? 2n minus what? 12 minus n plus 1 equal to 0. You should remember that wherever we see the n, we are putting there the expression 2n minus what? 12, which we are now going to what? Expand and then simplify as in this case 6n minus 36, and that is the expansion for this part, minus n plus 1 is equal to 0. So from this we have succeeded in making the n the only variable in our equation. So we have removed one of the variables, which will end up giving us 5n minus 35 is equal to 0. So if we work out the variable parts, I'm getting what? 5n. And if we work out the value part, 36 and 1, we are getting what? Minus what? 35. And therefore, 5n is equals to 35, n is equals to what? 7. So that will be our result. Remember here there are two, as a litmus student, we have two options. Either we divide both sides by 5, or we know that which number multiply 5 to give 35, and that number is what? 7. And no one will actually expect that stuff from you. So n is equals to 7. If n is 7, then what is our m? That's where this also becomes very important, because it's also set to up to find n with ease, giving us m to be equals to 2 multiplying 17 minus 12, which will give us 14 minus 12. So m is equals to 2 in that regard. So we have obtained our m and n using the correct condition that was given to us. Therefore, our polynomial p of x can now be written as m was 2, so 2x squared minus That's n, so it's 7x plus what? 3. Now, if this was a work I was doing on my own, I have gone through this and I'm a human being. I wasn't using a calculator, or even a calculator can make a mistake. Then cross-check to be sure that if you should work out this, factor this result, you are going to get the solution this year being correct before you submit your work. You may actually end up not getting this result. You go back and you see the kind of mistake or the blunder that you committed, then you do the whole correction. Remember, making a mistake in mathematics is not an issue. It's when you submit it for marking. But if you make the mistake and then you make sure that you go over your work and then you see your mistake and you get it corrected, that is not an issue because you should remember your money. But when you don't do any check and you just, let's check this one. We know we are going to multiply 2 by 3 to get what? Our 6. If we do that, which factors of 6 will produce what? 7. You know that it's going to be what? 1 and 6 is 7. Which 7 are we looking for? We're looking for a minus 7. So each of them becoming what? Negative. So that minus 1 and minus 6 will become minus 7. So we know already by a simple this that we're having 2x minus 1 and 2x minus 6. A bracket here saying that. But then the factors of 2 are 1 and 2. So 2 can divide it by 1 and 1 by 2. Don't worry about this pattern, but you have any way that you are using to do your factorization with accepted. So you are getting 2x minus 1, then x minus 1 as my factorization equal to 0. So that if I'm solving this equal to 0. Therefore, my x will equal to 1 and 2. That's when I put this one 0 or 0. So I know for sure that this result is what? Correct. Then we have actually got not messed up anywhere. That's if it's an assignment and you finish this work, you have all the time to submit your work. You should do this once, but not as part of the work. Anyway, can we go to the next example? We have some time. This example says that h of 2x minus 1, that is our h of 2x minus 1, is equals to x cubed minus 2x squared plus 10. Now we are still in the formal theorem, so we simply think like this. So we are supposed to evaluate the first one, I, h of 3. Let's give ourselves some few seconds try that. Just observe it. That's h of 2x minus 1 is equals to x cubed minus 2x squared plus 10. And we are in the first instance supposed to evaluate h of 3. And remember what makes this one a polynomial are that all the exponents are positive. So you can be h of x, g of x, anything at all. But then the description is which type of polynomial is it. If we remember what we said, this will be a cubic polynomial and a trinomial. In that case, like 3 of length and the highest power is 3. Maybe when doing that, we take advantage to do this. Let's just continue with that and let's take. If I should have a special case here, just by the way, because we don't have this. Usually done. If I have this, for example, h of xy is equals to 6x squared y plus 5xy. This is a polynomial involving two maybe variables. In this case, we are going to consider the powers. This has power 2 and power 1 in that regard. Therefore, 1 also here. So if we start adding the powers, what are we going to get? We are going to end up with 1 plus 2 giving us what? 3. And 1 plus 1 giving us 2. So this one will be said to be a polynomial of degree 3. Indirectly, a polynomial of degree 3. Polynomial of degree 3. And I hope we are done by now. Let's continue with our solution quickly, since time is not on our side. We have to make lots of observations on this. This is h of 2x. This is saying that when the expression in the bracket is 2x minus 1, then we should put only the x in the right hand side. So we should compare the left with the right. So simple way we can go about that, we are evaluating h of 3. So what do we see? Just compare, let's compare these two things. I have my h here and I have an h here. We have a bracket opening and closing. We have a bracket opening and closing. So what does it imply? Whatever is in this bracket is equal to whatever is in this bracket. So we can even do a simple issue of saying that before evaluating, 2x minus 1 should be equals to 3 because we are evaluating each of what that. And this is going to give us 2x is equals to 4, x is equals to 2. Which means that 3 could have been written as 2 times 2 minus 1, which takes the format 2x minus 1. Therefore, x will be what? Our 2. So in evaluating h of 3, we are not going to substitute 3. We are going to substitute what? 2. So this is going to be what? Each of 3 is equals what? 2 exponent 3 minus 2, 2 exponent 2 plus 1, which will give us 8 minus what? 8 plus 10. And that is equals to 8. Take note of this kind of work, where you have 3 here, where you are putting 2. Reason being that the expression says that if we express the number that is there as 2 times an x minus 1, given that result, then put the x that came out into the expression. And therefore, if we have 3, it's when we add 2 times 2 minus 1, that will give us 3, which we just found by equating the two results. One way of the simplest way is just equate the 2 items in the brackets, and that's your result. So if we are doing h of what? Minus 7, we're going to follow a similar procedure, and I hope you can now do that one with ease. We're now going to evaluate h of minus 7. So h of minus 7 will be equal to is what we are now going to evaluate. As we've already mentioned, the minus 7 is now representing the whole of 2x minus what? 1. So we are getting, this one will imply that we are having 2x minus 1 being equal to minus what? 7, which will give us 2x mean equals to minus 8, and then x mean equals to minus 4. So actually we are evaluating h of minus 7 as putting x into the right hand side expression. That's minus 4. So we are getting negative 4 to power 3 minus 4, negative 4 squared plus 1. That's going to give us negative 1. In this case, 64 minus, this is going to be a positive 16 by 4, also giving us 64, and then plus 1. So we are getting what? Negative 1 what? 28 plus 10, therefore plus what? Negative 1. So that's our final result. I suppose the process is clear. We'll just concentrate on this video just on polynomial functions and how to evaluate polynomial functions. Later discussions will concentrate on more topics under polynomial functions. Next period that we have to us. I will take the next set of examples. Now let's go for a commercial break and come with our exercises to continue doing whatever we are doing over here. We will give you some exercises with some selected options. We apply the issue to the case of objectives. Remember that in examination, during examination, we apply for both theory and objectives. Sometimes we over-concentrate on the theory. So let's go for a small commercial break, and when we come back, we'll continue with our discussion. Welcome back from our commercial break. We will actually be taking some exercises and taking calls for it. Our first 3 exercises as projected on the screen. The first one is a polynomial with degree 4 is called what? As we just mentioned, a polynomial with degree 4, and this is objective in nature. Our first one. Then a polynomial with degree that we have linear, cubic, quartic, and quadratic. Can pick your option. That is looking this way. Second, if f of x equals minus 2x squared plus nx plus 2, and f of minus 1 is 2, you have to find the value of what? N. Then the domain of a polynomial function defined for all real numbers. Now, let's get our numbers that we are going to use to do our call if we need any assistance. We have 0, 2, 0, 7, 5, 7, 5, 6, 6, 1, 8, 5. Let me repeat the number 0207 566 185. Or we can also use 0543 29 1074. I repeat 0543 29 1074. Any of these numbers line can be reached out to produce your results or to ask any question regarding polynomial that you need clarification on in our discussion. Maybe I'll repeat the number again 0207 566 185 and 0543 29 1074. Suppose we just do the calculations that we have on the board. The first one is the degree, the polynomial of degree 4 is called what? And if f of x is equal to 2 minus 2.
Hello.
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 Hello, we can hear you. Can go on with your question.
Hello.
Hello, we can hear you. Can go on with your question, please.
What you are saying, you are going to
I understand. I get you.
what you are going to now.
I get you. We'll slow down small for you, okay? And that's how we project. So I think when this is actually an introductory class, so most of the things that we are discussing, I hope that by this time we have some exposure into. But when we start solving questions and doing more, this will just be slowing down. So I get your point on that. Any other question on that? Okay. Well, then our third one, the domain of a polynomial function is defined for all real numbers, true or false. And here, we didn't actually say much about domain, but we define the function in our area of discussion. Apply that one here, you see the domain. That is, we said that the function or the domain of function should be the values for which the function is defined. That is value that when you put in, you get an answer. We've done a number of examples, whether we had a case. Okay, let's take a call. Hello, you can hear you, please go on. Good morning, please, you can hear you, go on. Your name and where you are calling from, please. Hello, we can hear you. Your name and where you are coming from. Okay. So we have a polynomial of degree 4, that's the two. Can we get the next 2 questions? Now question number 4, P of x is equals to x squared minus 6x. Please. Hello, good morning. Your name and where you are coming from. Or you are calling from, please. Okay, couldn't stand. So P of x is x squared minus 6x plus 4. Hello, good morning. Please, your name and where you are calling from.
My name is Evan. I'm calling from Kane.
Okay, please, you can go ahead with your question.
Hello.
You can go ahead with your question, we can hear you. Go on with your question, we can hear you, please.
Please, my name is Evan. I'm calling from Tema.
Okay. Tama, let's go on. We can hear you, please. Well, let's continue. P of x squared minus 6x plus 4. Please, you can continue calling. Yeah, I think the line is not happening. Hello, good morning. Where you are calling from, please? Your name and where you are calling from. Hello, good morning.
Hello.
Your name and where you are calling from, please.
Please, my only question is about the previous.
P of x equals x squared minus 6x plus 4.
The last section.
If P of x equals minus 4, find the possible values of x. And the last example we have here is given that f of x minus 2 is x squared minus mx equals 3. And if f of 1 is equal to 6, find m. Each of them is an objective contest. And you have your options there. Quickly go through and make your suggestion or selection. Call us.
Hello.
Hello. Good morning.
Hello.
Your name and where you're calling from, please. Your name and where you're calling from.
My name is Frank.
Yeah, go ahead with the question.
Hello.
Hello, we are listening.
Yeah, my name is Frank and I'm calling from North Carolina.
Frank, you can go on.
Okay, please, the previous question that you saw about the h is bracket 2x minus 1.
Yes.
With that, we set negative 35 as the answer, but you had something different.
You had what as an answer? Which of the solutions?
About h is bracket 2x minus 1. Yes,
And
I had maybe x to be negative 35 and you had something different.
Is it the I or the II?
The I, sorry.
The II.
The h is bracket minus 7. The I.
So if h equals minus 7, then
Yes.
possibly our difference might be on what we got for x. Let's think of what you got for x as a result. We have 2x minus 1 is equals to minus 7. Did you get x to be equals to minus 3? Is that what you had? That is this is going to become what? Let's just go down to x is equals to minus 6. X equals to minus 3. Did you get the same result as your x?
Yes, but I had 2x minus 1 equals minus 7. You get x equals minus 6.
No, you don't get x equals minus 6 because 2x is equal to minus 6. And for that matter, x will be equal to minus what? 3. You are solving a simple equation of the form 2x minus 1 is equals to minus 7. Paul, please, can we go and go on to another? Good morning, your name and where you're calling from. So, we are having a case of 2x minus 1 is equals to minus 7. Please don't forget about the existence of these two. So, we are going to get 2x is equals to minus 7, then x minus 6 and x equals 1.
Yes.
Good morning.
Add the minus, put it in the equation.
Yes.
You will not get the what you add, you get minus 6.
Okay, so h, let me clarify what we are doing mathematics now. Minus 3, h of minus, so h of minus 7. We'll be putting in that, and that should even be an issue, just an evaluation issue. What we are interested in is how to obtain this or what? Minus 3. In the evaluation issue, remember that we are not using any calculator. You're getting negative 20 what? 7. That's the case. That is negative 3. So let's verify that maybe we didn't do that. Minus 2.
Yes, but if you put you put the minus in the equation, you get minus.
If you do not evaluate, so you're getting minus 21. 7. And this is going to become what? Positive 1. 9. I will evaluated that one to the end, but this will be positive 9. So we are getting what? Minus what? 18 down the case. Plus what? 10. Which will end up giving us. This is going to give us a call, please.
Hello.
Hello, good morning. Your name and where you're calling from?
My name is Elective and I'm calling from Elective.
You can go on with your question.
I want to ask a question.
Go ahead.
I want to ask whether what you are using for
It's what?
or
Well, the interesting thing about mathematics is that you treat a topic, not a level. So once you're treating polynomial, it will be for, in some school, based on how fast maybe the students are, by the end of the third term, they will be doing polynomial. In some other school, maybe based on how slow they may be moving, they will get to form 2 before they will do what? Polynomial. So it depends on the order in which your tutor or teacher is arranging your topics. So this, we don't actually refer to any topic as Form 1 or Form 2 technically. We only arrange them by which one should be done first before another. So maybe your teacher just thought that, well, I want to do maybe calculus my first year, my first semester in Form 2. Therefore, I want to introduce the children into what? Polynomial third term in what? In Form 1. The order in which the teacher wants to sequence the topic Yes, although there's some general way on how to sequence, but then there are some variations. So that one cannot be as form 1 or form 2 in that regard. The most important thing is that some will treat functions and then leave it and do polynomial later. Some will just do it straight in hand. So I hope your question is answered. Can we move? So I think I'm getting you on that. So if we decide to go by this one, but I wonder if we even evaluated the work to this level, maybe you had a different answer here. Then this is going to become negative 10, 5, 8, which will actually give a negative 35, yeah. Then if you are getting that, that is correct in that regard. And remember that once you have your calculator to display that, I can't remember what exactly we done. To the questions, I hope. Still having some few time to discuss the question that we have in there. Well, now let's come to the end or concluding part of our work here. This is the beginning of our topic on polynomial. We're moving into more maybe serious things as time goes on. Today was mainly for introduction. So if we have any interest in what we are doing and you want to sponsor Kane e-learning, you can reach us on the line 0242 885463. 0242 885463. We want to develop this into an e-learning platform that will assist students in various parts of Ghana, both during our trial period and end of the trial period. So if you want to sponsor us, you can just reach us through the number 0242 885463. And if you have any issue regarding some of the things that we did here, aside the normal calculation that you can actually verify that this was actually omissions and error, you can easily call us on that. And we can also add the number 0249759062. This will be the number you can reach us on after the lessons too. If you have any clarifications, you say that 0249759062. You can reach our other tutor on the line and he'll be there to answer all your questions. Thank you very much for listening. My name is Adam Sabas, and I will be with you from now going, taking over the elective mathematics, while my other tutor takes over the core maths. Thank you very much.